Alright, Algebra 1. Today we are working on rearranging formulas. That would just mean an equation with lots of different letters and numbers that you just have to learn to move stuff left and right of the equal sign, multiply, divide, etc. to solve for a certain variable or a certain letter. So let's start out. Let's solve each of these equations for x. These are the things we've been working on for quite a while. And it should be getting easier for you as you work. So as I solve for x, I'm going to get rid of all the numbers and get x by itself. So here we go. I've got 2x is equal to 16, therefore x is equal to, well, let's do all the work. We can do that. Divide both sides by 2, therefore x is equal to 8. With this next one, I need to get x by itself, so I need to move this minus 3 by adding it to both sides. Negative 12 plus 3, negative 9, divide by negative 3, I get x equals positive 3. Okay, for this one, I'm solving for x. I know, this looks crazy. I've got letters and numbers. Treat them the same way. If I move it algebraically by adding, subtracting, multiplying, and dividing. C plus B, I need to get that A out of there. A is in the multiplication spot, so I do the opposite, which is divide. And I don't have a pretty answer, but I have an answer, which is correct, right? All right, number 2 says compare your work in parts A through C above. Did you have to do anything differently to solve for x in part C? No, I added, I divided, and I found my answer. So no, everything always works the same. I can't spell, sorry. Nothing different. All right, so let's look at this one. Solve the equation ax minus b equals c for a. If I remember, part C was ax minus b equals c, and I solved it for x. This time I'm solving it for a. So add b to both sides, because I want to cancel that out. I'm left with ax equals c plus b. Now if I'm solving for a, I need to divide everything by x to get that a by itself. A equals c plus b over x. Nothing different there. Here we are, rearranging formulas again. These are very familiar formulas, like the area of a rectangle is length times width. On this particular problem, we're given that the area of a rectangle is 25 inches squared, and the formula is area equals length times width. So for this particular one, if the width is 10 inches, what is the length? So I know that area equals length times width. I'm going to divide both sides by 10, and I'm left with the length equals 25 divided by 10 is 2.5. Don't forget your units, inches. That's what we're doing when we rearrange formulas. Okay, we're just solving for a variable that we don't know what it is. Same problem, I know the area is 25 equals length times width. Here, this time the width is 15 inches, so if I divide both sides by 15, I'm left with length equals 25 over 15, which can reduce to 5 over 3 inches. Don't forget your units. Rearrange the formula to solve for L. It's halfway done for you there. I have area equals length times width. I divide both sides by width. Those cancel out, and I'm left with length equals area over width. Verify that the area formula solved for L will give the same results for L as having solved for L in the original area formula. Well, it is length equals area over width, which the first problem we had was 25 over 10, which is 2 2.5. In the second problem, we did 25 over 15, which I'm just going to reduce that to 5/3. This one actually reduces to 5/2. So it's the same thing. Okay, we're rearranging formulas that you may see in a science class for different variables. Exercises 4 and 5, solve each problem 2 ways. First, substitute the given values and solve for the given variable. Then, solve for the given variable and substitute the given values. So for this first one, I have the perimeter formula for a rectangle is perimeter equals 2 times the length plus width, where P represents the perimeter, L represents the length, and W represents the width. Calculate L when P equals 70 and W equals 15. So first I'm going to plug everything in and solve for it. So I've got 70 equals 2L plus 15. Let's see, I'm solving for L. 35 equals L plus 15. Subtract 15 from both sides. L equals 20. Second way, they wanted us to solve for the formula first and then plug things in. So I have P over 2 equals L plus W. If I subtract W from both sides, I get P over 2 minus W equals L. Cool. For this one, I'm writing over here, I could actually plug in everything that's given. 70 over 2 minus width equals length. 35 minus width equals length. 20 equals length. I do get the same answer. Sorry, I'm creeping on B's space. Area formula for a triangle is 1/2 base times height. Calculate base when area equals 100 and height equals 20. Okay, I'm going to simplify the right-hand side first. 1/2 of 20 is 10, and then divide both sides by 10. 100 divided by 10 is in fact 10, so your base is 10. Now let's take the formula and just solve for B and see what happens. If I multiply both sides by 2, it gets rid of the fraction, and then divide by H. I get B equals 2 times area over height, which equals 2 times 100 over 20. 200 over 20 is in fact 10, and I get the same answer. Rearrange each formula to solve for the specified variable. Assume no variable is equal to 0. This right here is like what we did in lesson 18, where whenever we had a variable in the denominator, we would have to say x cannot equal 0. Here we're assuming no variable is equal to 0, so we can just solve things and not worry about the denominators. So here I'm going to solve for P. If I have area equals P1 plus RT, I don't even know what this formula has to do with at first glance, but I can still solve for P. So if I look, this whole thing is multiplied by P. So I can divide both sides by 1 plus RT. I certainly don't want to distribute that P first and then mess with it. That would be awful. Because this is in parentheses and I'm dividing by the exact same thing, I can cross the whole thing out. So I know here that P equals A over 1 plus RT. Let's do the same thing but solve for T. I have A equals P1 plus RT. I actually want to move that P out of the way this time because it's in my way. I'm trying to get R by itself. So that gives me A over P equals 1 plus RT. I'm trying to solve for t. So let's move this 1. I have a over p minus 1 equals rt. This may not have been the best method, but I think I'm going to do it again when I'm done and show you a different way. Still trying to get rid of this, or get that by itself. So I divide both sides by r. So I have a over p minus 1 over r equals t. Now if you'll have patience with me, I'm going to show you one more way to solve for t. Hopefully this gives some of you the confidence that there's more than one way to solve an equation. This time I'm going to distribute the p, so I'm going to multiply it through p plus prt. And this time I'm going to go through similar steps. A minus p equals prt. Now if I remember right, I'm solving for t, so I'm going to divide both sides by p and r, and I'm left with t equals a minus p over pr. Now the equation on the previous slide and this one, they are equivalent. That means they're both correct, which is cool. All right, now we're solving for m. So we want to move everything over to the other side of the equal sign. The first thing I always do is get rid of fractions. So multiply everything by 2. I get 2k equals mv squared, and then divide by v squared. I'm left with m equals 2k over v squared. And remember, we assume that there are no variables that equal 0. And then this next time, we're solving for v. So let's multiply everything by 2 again. I get 2k equals mv squared. Get rid of that m. M is currently multiplying, so I have to do the opposite, which is divide. So 2k over m equals v squared. It's a square, so I need to take the square root. I get v equals the square root of 2k over m. I did forget the plus and minus. Now, this blank slide is for me to remind you to ask lots of questions. This stuff can be hard if your solving skills aren't that solid. So ask lots of questions and come for help. I'm available before school while you guys are hanging out at the Innovation Center, and after school. Miss Madison and I are available either day. If I'm not here, she's here. If she's not here, I'm here after school. But you need to ask questions if you need help. Cool? Cool.